more about ellipse. All right, so one thing I need to mention about ellipse is the focus formula. The formula for focus of an ellipse is c squared equals a squared subtract b squared. You might notice it's kind of similar to that in there, but it's different. You got subtraction sign. Now, you may ask, what in the world is an ellipse anyway? So I think dictionary.com could explain it just as well as me. All right, so this is how they define an ellipse. So they define it as a plane curve such that the sums of the distances of each point in the periphery from two fixed points, the foci, are equal. All right, so basically what they're saying is you got a curve, and like a circle is a set of all points from one distinct point. That's how you form a circle. You got one distinct point, and that radius is the same all the way around, creating a perfect circle. An ellipse, though, it's formed using two distinct points. And it's saying that the distances from both of those, it's formed by the distances of both of those points, and the sum of these distances being the same. It's kind of hard to say, isn't it? So actually, let's look at this. Let's look at it a different way. So try to explain it better. All right, so you notice A here is this red segment, and the same thing as A value here, the same length. And blue segment here is B, all right, and the same length here. And what we know is, in an ellipse, A plus B will be constant, and that constant will always be equal to the major axis. So you're going to notice that this length and this length is always the same. So that any point on this ellipse is formed by a length of A and B. A and B may be changing depending on what the point is, but it's still creating a length. It's still, when you add them together, it still adds up to equal to the major axis. Right there, it's clearly equal to the major axis. You go around on this side, A is smaller than B, then A equals B, now A is bigger than B, and so forth. So anyway, that's how you form an ellipse. You're basically getting the set of all points the same distance from two distinct points. So those two distinct points act together to form the ellipse. Now these two distinct points are called the foci. If I take one of them, or I take them both, and I start moving closer and closer to the center, look what it's doing to the ellipse. We're looking more and more and more like a circle. So right, when the foci are all on the center and they're all the same place, A and B are the same length, and that means that they're always in the same length, and now you just create a circle. So a special type of ellipse got special properties other ellipses don't have. All right, so that's what happens when the foci get really, really close together. If you stretch it all the way out and make the foci further and further out, closer to the vertices, it gets like really flat, almost a line. Eventually it becomes a line. Take it all the way out there. So that won't be much of a shape to look at. But anyway, so that's just a special property about ellipse. If you kind of want to play with it, the website I got this from is called, how can I explain? Here it is. I'll write it down. It's called mathopenrough.com. All right, if you type in ellipse.html goes there. But you got some other resources too on circles and all kinds of other stuff. But yeah, it's mathopenrough, OPENREF.com. All right, moving on. All right, new example. So it's write an equation for an ellipse with foci at -4, 0, and 4, 0, center at 0, 0, and major axis at 10. Now, me personally, when I see all this, I don't even think about the algebra to it. I go straight to geometry. I just start drawing everything they told me until it starts making sense. So the first thing I'm going to do is actually graph it. All right, so it says the foci are at -4, 0. So at -4, 0 is one foci, and 4, 0 is another foci. So I know that's my focus, and then my center is here. So, and they told me that my major axis is 10. But I know my foci is here. I know my major axis lie in this direction. And if my major axis is 10, and my center is 0, 0, so if my major axis is 10, major axis equals twice A. So I know that 2A equals a 10, so A has to be 5. So I know A has to be 5 from the center. So when I 5 this direction, that'll put me here. When I 5 this direction, that'll put me there. So this is the vertex. This is the other vertex. And this is all I have so far. I don't know the coordinates for my minor axis, so for my covertices. So what I do know is, though, that my focus value is basically the C value. C, where the distance from the focus to the center is C. So if this is my center and my focus is at 4, I know C has to be 4. So I know that the formula says C squared equals to A squared subtract B squared. And I want to know B, but I do know C is 4. I decided A was 5. And what I don't know is B. So this is 16 equals to 25 subtract B squared. Subtract 25 from both sides. And negative 9 equals a negative B squared. Do the math there, divide by negative 1. So positive 9 equals positive B squared, and 3 equals a B. So I know that the B value has to be 3 away from the center. So this is my center, this is 3 up, and this is 3 down, and this is the ellipse. Alright, so I know A, and I know B, and I know my center. I got everything I need to write the equation for that ellipse. So the equation for that ellipse must be, I'm going to need some space, so a lot of this stuff got to be erased. So I gotta use the space. So if you need any of this, I'll copy it down now before I erase it. Alright, so this is the formula that we're working with, because this formula has the bigger value beneath x. And that's where it should be, because it's a football-shaped graph. And I would basically write the formula as x subtract 0 squared all over a squared, so that's 25. A was 5. Plus y subtract 0 squared all over b squared, so that's 9 equals 1. Do I have to write the subtract 0? No. You probably would have wrote x squared over 25 plus y squared over 9 equals 1. And I would like the answer better. So I'll write it this way too. So that's the equation for that ellipse that has that happening. All right, let's do another example like this one, where they give you details and you have to find the equation. Give you clues and you have to find the equation. All right, so this is a new example. It says write the equation for an ellipse. It has foci at 2, 4 and 2, negative 4 and a minor axis of 6. So if you think you got it, go and pause the video and give it a shot on your own. So pause the video and give it a shot by yourself. If you don't think you have it, just wait on me. I'm going to eventually explain it. All right, now pause the video, give it a shot. All right, so if you didn't pause it or you unpause it, this is what I would have done. I'll first graph these foci. One's at 2, 4. So go over 2 up to 4. One's at 2, negative 4. So this is what I know for sure. They didn't give me a center this time. But this is what my foci are. My center has got to be, well, how would you notice? Well, if this is a focus, and this is also a focus, where would you think the center must be here? Well, you probably think it's got to be halfway between there. You'd be right. So I know my center has to be somewhere in the middle of that. So I know my halfway between there is here. So I know my center is at that coordinate. Center is at, it looks to be 2, 0. So in the rectangle, I know h and k. H has to be 2, 0 has to be k. All right, so this is my minor axis was 6. So I know that 2b has to be 6 because 2b equals my minor axis. So no, b has to be 3. And if my foci are in this direction, I know my minor axis has to be in this direction. All right, so it has to be 3 to the right. So this is like it's counted by ones here. So 1, 2, 3, and then 3 to the left. 1, 2, 3. And I haven't found my A value. But what I do know is I know B and I know C. If my focus is here, this length here is C. And that length is coincidentally is 4 again. So I know C has to be 4. Alright, so I know the formula says C squared equals to A squared subtract V squared. So 4 squared equals to, I don't know A, but I do know B is 3. So 16 equals to A squared subtract 9, add 9, 25 equals to A squared. So I know A has to be 5. So I know A, I know B, and I know my center. So I know enough to write the equation for this ellipse. So this equation has to be x subtract 2 squared plus y subtract 0 squared equals to 1. And on the bottom, the A value in this case must be beneath y, because this is an ellipse that goes up to here and down to here. So it's an egg-shaped ellipse. So because of that, I know my C value, my A value has to be beneath y. So it's 25 beneath here, and 9 is beneath there. And this is the equation. That's it. Again, that says y subtract 0 there. Make it look a little better. Y subtract 0 over 25 equals 1. And that's it. That's all I have on that topic. One last topic to talk about in this area of ellipse. So I copied anything you didn't already know, and I'm going to give you one last note. All right, area of an ellipse formula. Pi times A times B. Pretty easy stuff. So if I gave you an ellipse, and I said it went out to say 5 in this direction, and it went out to say 4 in that direction, I know that my A value is 5. I know my B value is 4. So the area will equal to pi times, oh, that's not a 4. That's a 4. So pi times 5 times 4. 20 pi. So the area of that ellipse has to be about 20 pi. All right, that's pretty much all I have. That's it. Good luck.